Hello, I just wanted to take a few minutes to go over question 2 because I went a little astray during lecture. It wasn't quite as tricky as I was making it. So the asterisk tells us that this individual does not carry the diseased allele. And so that is the first important point that we need to think of when we're looking at this pedigree. The second thing that we need to see is if this is a recessive disorder or a dominant disorder. So I look in this generation and dad has it. This generation, no one has it. This generation, we have a son with it. And then this daughter pairs with a male who also has the disease, but is not part of this family. So we have dad, skip a generation, and grandson, I guess this would be. So whenever we see a generation skipped, we know we're dealing with a recessive disorder. Is it autosomal or is it X-linked? We're going to approach this by looking at this son, okay? Because he has the disease, we know it is recessive, but he has a parent who does not have either allele. And that information tells us that it is X-linked, and it is X-linked because you get your X from your mom if you are a male. Okay, and if we go back, mom is a carrier through her dad. So dad passed on his recessive X to mom. This mom passes on her recessive X to this someday dad, I guess. So that is how it is over here. Now, here is where I screwed up, because when I looked at this, I was like, oh, this can't happen, but of course this can happen. Dad passes on his recessive X to this woman. She is a carrier, and her son just did not receive the recessive X. He received the X that has the dominant R. This daughter may or may not be a carrier. So we've got this covered. Now let's go over to here for these questions. So genotype. This individual could either be heterozygous or homozygous dominant on the X. So it would be X big R, or X big R, X little r. This individual, because she has a son with the disease, but she does not have the disease, is definitely heterozygous. Okay. And now here's where things get tricky. This individual has a 50% chance of passing on her diseased X to this individual. Okay. But the question asks about A. So here's a 50% chance of it being passed from here to here. And then if she gets the allele, there's a 50% chance of it being passed from here to here. In these cases of probability, there is a multiplicative effect. So we're going to multiply 1/2 by 1/2, and this individual is going to have a 25% chance of having the disease because dad has it, so that's the only X that she can get. Mom is a potential carrier, 25% chance. If we knew mom was a carrier, it would be a 50% chance. But we don't know that she's a carrier. We have to go back to grandma. Did grandma pass it on? We don't know. There's a 50% chance. If grandma passed it on, there's a 50% chance that she would pass it on to her daughters. Okay? And it's the same chance with the son because this is X-linked. Dad is only going to give his Y to this individual. Right? So it doesn't matter that he's diseased for the son. We still have to go back to grandma, 50% chance, 50% chance. We multiply 50 times 50, and we get 25 it's 0.5 times 0.5, and we get 25%. Okay, so hopefully that makes more